demonstration, we'll be running through the deduplication engine of the CluedIn platform. Let's start by uploading some data. In this particular case, we have some products we're going to upload. This is a set of products that are coming from a system called Navision. So let's upload it in a folder called Navision in the staging platform inside CluedIn. Here we have 10 rows, and you can see that it has a SKU. This is an identifier of products. It also has a name of the product, and it also has a size. Okay, so let's go ahead and map this data. Let's search for product. Okay, there already exists an entity type in CluedIn, so let's use it. There's a vocabulary as well, and you can see that this is the structure that CluedIn is going to create when it onboards this data. Let's create the mapping. Okay, let's edit the mapping, head to our entity origin, and let's choose the SKU as the unique way to identify those products. Click Next, Finish, and let's process those into the platform. As you would expect, I should have 10 records that are successfully pushed into the platform. Let's head over and upload the next file. In this case, we have another system called Yellow Systems. We're going to upload the products from that in a folder called Yellow Systems. Let's take a look at this. So 10 records. This time, however, we've got an item ID, and we've got a name of the company, a name of the product, and we've got a company ID. Okay, well, I don't see any ways to be able to link these records together. So I have a couple of choices. I could, for example, try and enrich this data with CluedIn's enrichers. I could also potentially try to wait for new files that may have the link between the item ID and the SKU. Or I can put through a deduplication project to use fuzzy merging to go off and do this. Let's map this data. Choose product. Now you can see it's already going to map to the product name that existed from the recent file that I just uploaded, but it will automatically create two new concepts called item ID and company ID on the fly. So think of this like we're evolving the product table along the way. Let's edit the mapping, head to our IDs, and I'm going to change it that the item ID is the unique way to refer to this object, and we're going to remove the company ID. Next, finish, and let's process that data into the platform. So in a couple of seconds, I should have my 10 records pushed into the platform, and then we can go and explore the deduplication part of the functionality. Let's head up to our search, and we should, if we filter by product, see that we have 20 records in the platform. And as you can see, there are obvious duplicates in the product data itself. Let's head to deduplication, and we're going to choose this on the end, the new deduplication projects. We're going to create a deduplication project called product duplicates. Now, we can choose to deduplicate across different types. This is useful when you've got types that are very similar, like people, persons, users, doctors, employees. You might want to actually deduplicate across multiple different types. In this case, we're just going to deduplicate by products. We can also set the limit of the size, and this is useful when you're working with large bodies of data. As you're creating your matching rules, you don't want to always have it run across the entire set. You want it to run across a sample set to make sure that you've built up your rules correctly. Only then, when you're happy with your rules, would you remove this limit and run it against the entire set of products. In this case, we have such a small set of data, we're just going to go ahead and create the project. Okay, you can see that it requires configuration. The first step is to create the matching rules. This is where we have our deterministic and probabilistic matching rules to be able to detect possible duplicates. Let's add a new matching rule called same name. In this case, we're going to start with the name property. We can choose from different drop-downs. In this case, we set the names of the products to both the name of the entity, but we could also just search for product.name, select, and then we get to choose our matching function. So in this particular case, we can be very deterministic. We can say where the names of the products are absolutely the same. We can also add normalizers to this function. What this does is it allows us to temporarily make changes to the product.name value just used for the actual matching of the clusters. It's not going to actually change the underlying data. So for example, to lowercase won't actually lowercase the name in the future, but while it's going off to detect duplicates, it will lowercase before it actually compares the different values. It's at this point where we need to ask ourselves, does white space have anything to do if products should be the same or not? And I would argue white space doesn't matter, punctuation doesn't matter, maybe special characters and diacritic characters also don't matter when we're comparing product names. We can click next, add the rule, and then it gives me a prompt to generate the results. So let's go off and generate these results. Now, this will give me a progress bar that goes off and finds the possible matches and then reports back when it's found possible clusters that are matching those matching rules that I set up. So our clusters are nearly done, and I should receive a message when my duplicates are ready to go. Okay, so here we have all of our clusters. You can see that it's picked up 10 out of 10 of the possible clusters. Let's go through and take a look at one of the individual clusters. And you can see that we get this comparison list, where here are the conflicting values, and here, collapsed automatically, are the matching values. You can see that health insurance the name and health insurance the name are absolutely equal. This is why it was brought up as a possible cluster. Now, in this case, we can see that there's actually missing properties on each of the records that came in. And that's just because they had misaligned properties. They didn't all work with the same structure. So you can see that the health insurance from one particular source had the company ID and the item ID of 9. And the health insurance record from the other source had a size of 654 and a skew of 1. This is where we can start to choose the survivorship rules. So in this case, this is a simple example where we choose from each of the different records, and this will merge all of those together. Let's click next, and we can see a preview of the final result. You can see the final result will now have all properties merged together with the company ID, item ID, size, and skew, and the other properties that were already matching, like the type and the name. Let's approve, confirm, and let's head back to our list. You can see that now the status of this cluster is set to approved. Let's go ahead and approve all. Let's confirm, and now let's go off and merge all the records together. You can see that it gives me a preview. It will now merge all of the 10 clusters that are set to a status of approved. Let's click next, and then we get to choose an option of how to handle if data had changed since we were working on these duplicates. You can probably imagine that while you're working on these projects, it might take 1, 2, or 3 hours to go through all the different clusters. And data may have actually changed in the time that you're working with these clusters. This allows you to choose how to actually handle those situations. In this case, I'm going to choose to skip the stale data. So I can always come back and build my new clusters in a new project later to handle anything that's updated since I've been approving my clusters. Let's click confirm, and now this will go off and run the merging of those results. Excellent. You can see that all my merges have been committed. I can also head to the merged entities to see here are the records that have all been merged through this deduplication project. Let's go back to our search. Let's filter by our products. And we can now see that we have 10 products, no duplicates anymore. Let's head into Bank for Life and let's head into the topology. We can see in a visual form that we had 2 records on Bank for Life, these 2 products here. And we can see that they were merged and linked together with this particular deduplication project. In fact, we can see here that the Bank for Life and the Bank for Life record were all merged together with this project we called product duplicates. At any point, we can easily go in and ask the record to now undo the deduplication merge at an individual record level, or if we head back to our project and head to our results, we can click Unmerge All. This will undo what this deduplication project has done, and this is just in case we made mistakes or we found better ways to build matching rules. You can always completely undo in bulk what these deduplication projects have done to your data.